Welcome to Sidon Institute. To do question 1, we're going to treat like the same way we've been answering question 7 and 8, because the question is also asking about how to find the empirical and the molecular formula of the compound. We have been told to say the material is found to composed of carbon of 38.7%, then 9.7% of hydrogen, and 51.6% of oxygen. They have been given them the molecular mass of the compound is 62.0 gram per mole. Then calculate the empirical and the molecular formula for the compound. Alright, this question I'm going to be very fast because we've been handling this kind of a question 2 times. So we are going to treat the percentages as the number of moles, okay? As the masses. Okay, so we are going to have, we've been given that for carbon, we have carbon, we have hydrogen, we also have oxygen. So we're going to have 38.7. I'm going to treat this as grams. It's one and the same. The 9.7 grams, then 51.6 grams. Alright, so what we are going to do next is to divide by their atomic masses. We say we have 12.01 here. Here we have hydrogen is 1.008. Then oxygen we have 16.0. We are having, these are grams, are in grams per mole, okay? These are in grams per mole. So now to find the number of moles, because it's what we are finding here as our first step, we are going to, so once we divide this into this, we are going to get we are getting 3.2223. Then for hydrogen we are getting this is very closer to 1, so it's 9.6230. Alright, then for oxygen we are getting 3.2250. Alright, so we're going now to look for the smallest number. Our smallest number is this one. Okay, this is our smallest number. So we're going to divide both by the same number. Okay, divide here, also divide, it's 3 not 2. 2, 2, 2, 3. Alright, so here we are going to have 1. Here we are going to have for hydrogen we are going to have 2.99, which we can round off as 3. Then here we're only going to have 1.0. Here for oxygen we're going to have something like 1.00, which we can just write as 1. Alright, so our empirical formula now is going to be C is 1, hydrogen is 3, then oxygen is 0, is 4. Since the oxygen is just 1, so our empirical formula becomes this. Okay, so now to find the molecular formula, we go first and find the molar mass of the empirical formula. I explained this in the previous video. I'm not going to take long answering this. So we find the molar mass of the empirical formula. We have carbon, which is just 1 atom. We said 12.01 plus hydrogen 3 multiplied by the molar mass of hydrogen, which is the atomic mass of hydrogen. There we say our oxygen, we also have 1, 16.00. So finding them here, we're adding this. When you punch this on your calculator, you're going to get a number which is equivalent to a number which is equal to, what is it, giving me 31.0034. okay, 31.0334 gram per mole. Alright, so what we are going to do next is to find the value of N, which is the ratio of the molar mass of the compound which have been given here. We also divide by the molar mass of the empirical formula which we are just from finding. Alright, gram per mole. The gram per mole will cancel. The number of moles becomes to be 1.997, which we can round to 2. The next thing is to find out the molecular formula which we have been asked, which is given by N multiplied by the empirical formula. Multiplied by the empirical formula, we have N to be 2. The empirical formula is actually C83O, which we are now expecting to have our carbon. Our carbon atoms are going to be 2. When we multiply by 2 there, since we have 1, H3 by 2 we have 6. Then oxygen 1 we have 3. Alright. So this is how simple you can also handle this kind of a question. So let's go ahead and do question 10. Alright. Alright, so in this video now, in this question now, we are going to find the relative atomic mass of boron. I've been given the boron to say that it has the 2 naturally occurring isotopes, 10B with relative abundance of 19.9%, and 11 boron to be with relative abundance of 80.1%. Work out the relative atomic mass of boron. So the relative atomic mass of boron is given by this. Okay. So the relative atomic mass of boron, okay, is given by this. Okay, we say relative atomic mass. In fact, this is the general formula for whole, which we can be given. We are going to say, we are going to have M1, okay, multiplied by the percentage composition plus M2 multiplied by also the percentage composition over 100. In some cases, you'll be finding, instead of M1, you'll be finding A1. It's one and the same. Alright, where this M1 is just showing this number here, the masses. We treat this to be the masses, okay? We are going to treat this to be the masses, 11 and 10 to be the masses here, okay? So, now to find the relative atomic mass, we are just going to replace. We are just going to replace. We are going to say our relative atomic mass now. What is our M1? Our M1 is 10, okay? Our M1 is 10 multiplied by its corresponding percentage is 19.9. Okay? We say multiplied by 19.9 plus our M2 is 11 multiplied by its corresponding percentage is 80.1%. Then we divide by what? By 100. Very simple. You punch that on your calculator, you're going to get the relative atomic mass of 10.8. Okay, to be our 10.8. As you can see now, this is even very closer. It is like an average of the two. The relative atomic mass is an average of the two isotopes. Okay, and I explained this why it is not always the whole number. So go and check out for the video where I explained this. This is exactly tutorial. This is lecture 2. Yeah, lecture 2. You find this on your lectures, right? If you need the video, you can also inbox me so that I give you the lectures, right? That so that you hold at your own free time. So this is how simple you can find the relative atomic mass. If you find the video helped, consider subscribing to the channel, like the video, also hit the notification button so that you may be updated about the new uploaded video. Thank you for watching. See you in the next video.